All this is note card 2 about limits. So what's a limit? All right, a limit is simply a y value that gets approached as a certain x value is approached. So let's see what Stacy says. She says verbally, if f of x becomes arbitrarily close to a single number L as x approaches c from either side, then the limit of f of x as x approaches c is L. So let's understand it graphically. So we have some curve which we're calling f of x here. Okay, and f of x has a hole, or the fancy word for that is a removable discontinuity. Okay, so as we follow this curve along and we get really, really close to this x value of c, now c just is in place of a number, okay, we're getting really, really close to whatever this y value is, which they're calling L. They're just using letters instead of numbers. So as we come in from the left side, we're approaching this y value, which we're calling L. And if you notice, coming in from the other side, okay, we're following this curve from the other side. Imagine this curve goes on forever. All right. We're also, as we're getting closer and closer and closer to C for an x value, we're also coming into L. We're getting closer and closer and closer to the same value. Okay, so that's graphically what a limit means. It's the y value that we get really close to as we come in close to C from both sides. Now, analytically, it says the limit of a function as x approaches a certain number equals this y value, and then there's this notation that says IFF, which stands for if and only if. That's a two-way conditional. Only if the limit as x approaches c with a little plus sign, which means from the right, equals the limit as x approaches c from the left of f of x, or the limit of f of x as x approaches c from the left. So this part means coming in from the left. Okay, so as we approach from the left, we're approaching c from the left, and that equaled L. And as we approach c from the right, we're also approaching L. As long as the left limit equals the right limit, and they both equal the same number, then that limit exists. Okay, so that's an analytical way to evaluate a limit. And lastly, we can do it with a table, or numerically. So it says from the table below, what's the limit as x approaches -7 of f of x? So here's my x values, and here's my y values. And remember, y means the same thing as f of x. So as I come in from the left, coming in from values smaller than -7, as I come in from the right, from numbers that are bigger than -7, remember these are negative numbers, so -6.999 is bigger than -7, and -6.99 is bigger than both of these. So as we're approaching -7, these x values of -7, what's happening to the y values? Okay, well, when I get really, really close, that value is 2.599. Okay, as I come in from the right, a number really close to -7 is 2.598. So we're getting closer and closer to 2.6. Now, this didn't even have to be here. Okay, we're getting close on both sides to a number that's relatively close to 2.60. And that's why the limit is 2.6. Okay, because we're approaching 2.6. That's the y value we're approaching, coming in from the left. And we're also, as we're coming in from the right, we have y values that are getting closer and closer and closer to 2.6. Okay. Now let's do some example problems. Let's look at the first example problem here. I'm going to zoom in a little bit for us. It says use the graph of f of x to the right, so they're talking about this graph. Define the limit of this function, so that's the function. This function right here represents this graph. It's basically a line with a hole in it. And again, the formal name for that hole is called a removable discontinuity. Okay. What happens as my x values get close to -3? So let's think about it coming in from the left and also coming in from the right. Okay, so here's -3. There's an x value of -3. Okay, and the function's not defined there. Okay, the function's not defined there, but that doesn't matter. So as I get really close, as I come in from the left to -3, and as I come in from the right along that function to -3, they're both approaching the same y value. Okay, we're getting really, really close along this function. And what y value are we getting close to? Well, as I come in from the left, getting really close to a y value of -5. So I'm coming in along the function from the right side. I'm also getting y values that are getting closer and closer and closer to -5. And even though there's a hole here, that doesn't matter for limits. As long as the left, as we approach the same number from the left and the right, the limit exists. Okay, so in this case, the right answer is -5, because that's what y value we're getting really close to. We're getting really, really close to -5. So that's a way to analyze it graphically. Now what about number 2? It says use the table below to find the limit as x approaches 3 of g of x. Okay, so I want to approach an x value of 3. So I want to come in from the left, and I want to come in from the right side. Now what do you notice about the y values? The closer I get to an x value of 3, what's happening to the y values? It's going 8.99 to 9.998. So my first thought is, okay, I'm getting closer and closer to a number that's really close to 10. What about on the right? So coming from the right, I get 9.99, 9.999. So as I come in from the right, it also looks, these numbers are both really, really, really close to 10. Okay, so that's what I'm thinking. So the right answer here is 10. And even though this shows me error, now the reason why it shows me error, it's probably something like this with a removable discontinuity. That's why it doesn't give me a y value, because y doesn't exist there. That doesn't matter, because it's all as we approach. It doesn't matter that the function is not defined there. Okay, so that's why this is 10. That's why the answer is 10 there. So now let's try problem 3. It says using the graph of h of x, so here on this graph, this is the graph of h of x. It says which statement is not true. Okay, so let's read each part and let's decide which one's true. What about part A? It says, does the limit of h of x as x approaches a with a minus sign, which means from the left, does that equal the same thing as the limit of h of x as x approaches a from the right? So here's my value a. Here's my x value a. So I'm going to focus in on that. Okay. So as I approach a from the left, I'm getting closer and closer to a y value of 1. So the left limit is 1. What about as I approach a coming in from the right side of a? Well, that's also the same number. I'm also approaching a y value of 1. So here, does the left limit 1 equal the right limit 1? Does 1 equal 1? Well, that's true. So the answer can't be A. The answer cannot be A. Or yeah, the answer cannot be A because this is a true statement. They're saying which one's not true. All right, now let's go to part B. It says the limit of h of x as x approaches c equals 5. Now here it doesn't give me a left or right, it just gives me a c. Okay, so does the limit equal 5? So we're going to focus in on an x value of c because that's what it says right there. Okay. So I get closer and closer and closer to c, I'd be approaching that value. So to me it looks like the left limit is 5. But for the limit to exist, it has to be the same on both sides. What about as I approach c from the other side? Does it also look like, as I'm coming in from the right, does that also approach a y value of 5? Yes, it does. So that works as well. So it's not that answer. Now what about part C here? It says the limit of h of x as x approaches b does not exist. So here's b. So what happens is I get closer and closer and closer to b coming in from the left. It looks like the left limit would maybe be about 0.5, a half. As I'm coming closer to b from the right side, the right limit would be 2. Now here the left limit is a half, but the right limit is 2. These numbers do not equal each other. And since these two numbers do not equal each other, this is true. The limit does not exist. For a limit to exist, the number coming in from the left would have to equal the number coming in from the right. These two numbers are not the same. So that's true. It does not exist. They're asking for which one is not correct or not true. So just by process of elimination, I know that that's the right answer. Okay, it says here the limit of h of x as x approaches c from the right equals 2. Well, here was my c. As I come in to the right of that, or from the right of that, I'm approaching a y value of 5. So the reason why this is false is because this number is not 2. I'm getting closer to 5. So if that said 5, I would be okay. But that's why D is not correct. If it said 5, then it would be correct. Okay. A few more examples here. It says, use this graph, the graph of g of x, to answer questions or parts A through F. So let's try to think about this. What's the limit of g of x as x approaches -3 with a plus sign, which means coming in from the right? So here's a value of -3. There's my x value of -3. Now coming in from the right means coming in from that side. The plus means coming in from the right side. Okay. Now if it just said -3 without the plus sign, well, the number coming in from the right is different than the y value coming in from the left. It would be D and E. It would be does not exist. But here they're only asking about one side. So as I come in from one side, as I come in from the right side, I'm getting closer and closer and closer to a y value of +2. Now the next part, what's the limit of g of x as x approaches -3 with a minus sign, which means coming in from the left? So there's where -3 is. As I'm coming in from the left of that x value, okay, I'm getting closer and closer and closer to that y value. And if I carried it over to the y-axis, that looks like -5. That's why that answer is -5. Now, if it didn't have the minus there or the plus, these two numbers are different. So here, the limit doesn't actually exist as I approach -3. Okay? The limit would not exist, but if we're only talking about one-sided limits, then we do put the values. All right, let's do the next one. It says, what's the limit of g of x as x approaches 0? Okay. So here's an x value of 0. So I come in from the left side, and as I come in from the right side, closer and closer and closer to that x value, it looks like the left side and the right side are approaching the same y value, which is right there. Okay, so from the left, I'm approaching -4, and coming in from the right, I'm approaching -4. So that's why this one is -4. Now part D, it says, what is g of -3? So that means when the x value is -3, what's the function value or the y value? So here's -3. If I look up, that's an open circle, which means that that's not part of the function. All right. But when I come in from this side, this circle was filled in. Okay. So this is actually the function value. It's the part that's filled in. It is a function value. So when x is -3, the y value here is -5. All right. Now part E. It says find the limit of this function as x approaches -6 with a minus sign, which means coming in from the left. Well, here's an x value of -6. Now coming in from the left would be over here to the left of -6, but we don't know if the function even exists over there. There's nothing on this side of -6. So because the function doesn't even start till right then, as far as we know, we would have to write DNE here, which stands for does not exist. I don't know what happens to the left of -6. Okay. All right, one more. It says, what's the limit of g of x as x approaches -1? Now here it doesn't have any pluses or minuses. So here's an x value of -1. Okay. And since there's no open circles or anything, we assume that's a filled in circle there. So what does it look like as I come in from the left of -1, as I come in from the right of an x value of -1, is this little arrow and this little arrow, the left arrow coming in and the right arrow coming in, are they approaching the same y value? Are they both approaching that point? Yes, they are. And what is the y value of that point? It's that number right there. It's 2. So we would say the answer there is 2. All right, problem 2. It says find the limit of h of x as x approaches 8 using the function h of x from the table below. Okay, so I want to get really close to 8 along the x. Okay, so I'm coming in from that side, from the left. Well, what do you notice about the y values? The y values are getting bigger and bigger and bigger. Okay, it's going from 8.21 to 19.47 to 26.7. Okay. So as far as we know, maybe we think that it's approaching maybe around 27 coming in from the right. But as we come in from coming in from the left, we might be getting close to a y value of 27. Now what about if we're coming in from the right side, as we get closer and closer and closer to 8 coming in from the right side, from numbers bigger than 8? What do you notice about the y values here? You're going from -8.21 to -19.47 to -26.7. These numbers match these numbers, but these are all positive, and these are all negative. So maybe from this side, maybe I'm approaching a number around -27. Now ask yourself, are these numbers exactly the same? Well, you might say yes, because, well, they both have 27 in them. But the real answer is, well, this one's going up, and this one's becoming more negative. So if you were to graph these points, Okay, if you were to graph these points, you might have something like this going on. Okay, numbers are getting bigger, okay, but here the numbers are getting smaller as I get closer to 8. Okay, am I approaching the same number? No, I'm not. This one's going closer to positive 27. This one is getting closer to negative 27. They're not approaching the same y value. So the right answer here would be does not exist. For a limit to exist, the number it approaches from the left and the number it approaches from the right have to be exactly the same. So number 3, it says graph f of x below, then answer the following questions. So a lot of students have a hard time with these because this is known as a piecewise function. Okay. And let's think about this. I'm actually going to do this on notebook paper. So I'm just going to rewrite it. F of x equals the piecewise function 4x over 5. I'm going to choose to write that as 4/5 x, which is the same thing. But that function's only good for x values that are between -5 and -1. And then you have a negative x squared. And that function's only good for x values greater than -1. So let's think about each of these parts. Let's think about graphing. Okay, think about this. Think about if you had y equals 4/5 x, which really means y equals 4/5 x plus a 0. Okay, well that's just a line. It has a y-intercept of 0. Okay, and then you would rise 4 and you would run 5. So that's how you would graph that function. Okay. Something like that. Now what about if you had y equals -x squared? Hopefully you recognize, well, that's a parabola. Okay. X squared goes like that. So -x squared would just be flipped over. So that graph would kind of look like that. Okay, the whole graph of it. But with a piecewise function, we're restricting what x is allowed to be. So we don't get a whole line, we only get part of a line. So here's how we're going to take care of piecewise functions. The functions themselves are going to look the same. Okay, let's think about this. Let's actually plot this out. This function, this line, this red line, it's only good for values between -5 and -1. Okay. So what would happen if I plug -5 in right there? If I plug -5 in here, 4 times -5 would be -20, and -20 divided by 5 would be -4. So when x is -5, the y value is -4. Now why is it a filled in circle? Because there's the little bar underneath there. Now what about, go to the other side, what about when x is -1? What happens when you plug -1 in there? 4 times -1 is -4 over 5. So -4/5 or -0.8. So when x is -1, the y value is -0.8, which is about right there. Not quite -1. It's a little bit above that. So there's the part of the line that we care about. So it's taking that red line above, but only focusing on it for a certain domain. So that's a certain part of this red line. Now, what about this graph, the parabola? That's only good for x values that are greater than -1. What would happen if we actually plugged in -1 here? You would do -1 squared, which is +1, but then you have to apply the negative in front. So -1. There's no bar here. If there was a bar, we would do a filled in circle at -1, but there's not one. So here, it's an open circle that's a little bit below this filled in circle. Okay, now what about the rest of the graph? Well, the rest of the parabola is just the same. Okay, it's going to be this part. And it's going to go on forever to the right. So that's what that piecewise function looks like. Okay. You can actually use your calculator to help you do this. I'm going to show you how. So if you go y equals, okay, under y1, here's the way I want you to put it in. Let's put a parentheses. Now let's do a fraction. We'll say 4x over 5. Now close the parenthesis. That's what the function was. Now put a division sign. This is actually only good between what? Between -5 and -1. So we're going to say something like this. This is only going to be good when the x values are greater. Oh, I'm sorry, I forgot to tell you how I did this. I went second math to get to this menu. And it's only good when the x values are greater or equal to -5. Then I'm going to go back under second math, and I'm going to toggle over to logic, and the x values are less than or equal to -1. Now let's put the second piece in. So I'm going to go parenthesis, and I'm going to say -x squared. Close parenthesis, then I'm going to put a division bar. Now that function is only good when the x values are greater than -1. Okay. Now let's just hit zoom and go down to standard. That's going to give us a standard 10 by 10 grid. Okay. So there's the line segment that we drew, and there's the parabola. There's the other part of the parabola. So this graph right here matches this. Okay. But let's really zoom in right there. Okay. So I'm just going to toggle over and toggle down, and I'm going to zoom in. So I'm going to hit zoom, and I'm going to go option 2. And then I'm going to hit enter. So notice, here's the line segment. And there's the parabola. Let's zoom in again. So there's the line. Remember, this value here, when I plugged in -1, that was -4/5 on the blue line. But when I plug in -1 there, it's actually -1. You see how there's a gap here. There's a very small gap, but it is important to notice. There's the gap. So there is a little gap in between here to the filled in part and the non-filled in part. So now let's use that graph to answer the questions. Okay. So it says here, what's the limit as x approaches 4? Okay, well, where is x equals 4? Well, 4 is way over here. Okay. If you kept this going down, you could find this. You could figure out how far down it would actually go. Now, since this is totally filled in and it's just a polynomial, the number I approach coming from the left and the number I approach coming in from the right are going to be the same. It's going to approach whatever the function value is. So how am I going to find that function value? Well, I'm just going to plug in I'm just going to plug in 4 right here. Okay, it's just part of the parabola. So 4 squared is 16, then we put a negative in front of it. In a way you can confirm this on your calculator, let me go back to the graph and just go zoom standard. Okay. If I hit trace and toggle down to Y2, if I just keep hitting over, okay, kind of does the step for me, but when the x value is 3.93, actually I'm going to type in 3.9. It tells me the y value is negative 15. What happens if I go 3.99? Negative 15.92, 3.999, negative 15.992. So this number is getting closer and closer to negative 16 as I'm coming in from the right. What happens if I hit 4.1? Tells me negative 16.81. What about if I go 4.01? Negative 16.08. What about if I go 4.001? Negative 16.008. Okay. Another way you can look at it is by a table. So if I go second window, I can start a table. Okay. And maybe I want to start my table at 3.99, and maybe I want to make my delta 0.001. And we'll just leave these as auto. Now actually go second graph. If I hit second graph, if you go over here to Y2, what's happening is I get closer and closer and closer to x values of 4. Okay, it looks like all these numbers are getting closer and closer to negative 16. What about if I came in from the other side? Okay, I'm getting negative 16.04, negative 16.03, negative 16.02. And the closer I go from the other side, coming in from the right, I'm still getting close to negative 16. Okay, now just because this says negative 16, that's not important. It's as you approach coming in from both sides. Okay, so that should confirm for you that the right answer there is negative 16. Now, what about the next one? What's the limit of the function as x approaches infinity? Sideways 8 is positive infinity. So I think about my graph. What's going to keep positive infinity is this way. Okay. So as I go further and further out on this graph, what's the function doing? The parabola is going to keep going down and down and down, and it's never going to end. Okay, so the further I go out, this is going to continue to approach whatever this number is. Okay, well, it's going to go down forever. So what my real answer here is, okay, the further I go to the right on my graph towards infinity, this is going to approach, it's going to go down forever. So it's going to approach negative infinity. But infinity itself is not a number. So a limit has to be a number. So I'm going to do two things here. I'm going to tell the reader what's going down towards negative infinity, but since I know that's not a number, I also have to write DNE for does not exist. Okay. That's what the important part is there. Okay. Now, the most important part here, C. What's the limit as x approaches negative 1? Now, there's no plus or minus here. Okay, so the only way this can exist is if the left limit would equal the right limit. So let me zoom in here. So here was negative 1. As I come in from the left, I'm getting close to negative 0.8. But as I come in from the right, this y value, I'm getting closer and closer to negative 1. So here the limit of f of x as x approaches negative 1 from the left was negative 4/5 or negative 0.8. Okay, that's coming in from the left side. But as I come in from the right side, the limit as x approaches negative 1 from the right, okay, coming in from that side, I'm actually approaching -1. These two numbers do not equal each other. And because these two numbers do not equal each other, we would say that this limit right here does not exist. That does not exist. I really don't know why I circled that, but I did. All right, last part. What's the limit as x approaches -5 just coming in from the right side? Okay. So here's where -5 is. That's an x value of -5. Now they're not asking me for a two-sided limit. They're just asking me for a one-sided limit. So this means coming in from the right. So as I come in from the right, I am approaching a certain number. What is that number that I'm approaching? I'm approaching -4. So I come in from the right towards an x value of -5, getting closer to a y, and getting closer and closer to a y value of -4. So that's why this one is -4. And lastly, it says, using a graphing calculator, find the limit of this function tangent of 1 over x squared as x approaches 0. So let me get rid of these two. Now, whenever we do calculus, we don't want to be in degrees. So before I even go into this problem, I'm going to hit mode. I'm going to go down and I'm going to change my degrees to radians. Everything in calculus has to be radians. Okay, so I'm going to go to y equals. And I want to type in that function, tangent, make a fraction, 1 over x squared. And just to start, let's just do zoom and go down to option 7, zoom trig, because tangent is a trig function. Okay. And look at that. Crazy, crazy stuff happens. Now, do we care about this whole graph? No. I only care about it as my x value gets really, really close to 0. So maybe we can change our window in here. I just want to focus my x values to numbers that are close to 0. So for instance, what about if I just switch it from -1 to 1? And maybe I'll scale by 0.1. Let's try to look at the graph there. Okay. You still see crazy stuff going on. Okay. I can't really tell the closer I get. It gets really crazy in there. So maybe we change our window again. Maybe instead of -1, maybe we start at -1/10. And we go to +1/10. And maybe in this case I would scale by 0.01. Same type of thing, still going crazy in between those values. So this graph is not helping me out. It kind of looks as I get really close to the y-axis here. It might look like it's coming close to a certain y value, right down here at the bottom, like just kind of estimating that might be like -2/3 or something like that, like right there. So let's just go ahead and try to trace. Maybe I would type in here, notice if it starts at 0, y equals, why isn't the function defined there? Because if I plug 0 straight into here, you would get 1 over 0 squared. Well, what's 0 squared? It's 0. You're not allowed to do 1 divided by 0 in math. Okay, that's why the function's not defined there. Okay, but if I hit trace and I go -0.01, it tells me that that's 0.3209. What about if I do -0.001? Now it's shifting down to a negative number. So crazy things are happening. So maybe on my table set here, I would start at -0.001, and I'd want to scale by 0.0001. Then look at the table. Okay. So look at all these numbers. As the closer I get to 0, the y values are jumping around uncontrollably. Some of them are negative, some of them are positive, so on and so forth. Okay. Now look at it coming in from the other side. Okay. So here, it's doing the same thing. When functions jump around like this, okay, it kind of looks like they're on each side of 0. Looks like negative 2.564, so that might be the right answer. So you might have to reset your table. Maybe you start at negative 0.0001 and go 0.00001. Then if you look at the table, right close to 0, it totally switches to a different number. It was negative 2.5 a second ago. Now it's negative 0.55. So when things jump around crazy like this with some of the trig functions, since it's jumping all over the place, the answer is simply going to be does not exist. Because you can't find, it doesn't follow a pattern. It's not nice and neat. Because when you think about tangents on your unit circle, it's going to change. If x was 0.1, that's going to be a lot different answer than if x is 0.01. It's going to make this whole thing much bigger. And depending on this radian measure depends on the sign of the tangent. Okay, that's why it's flipping out here. So these graphs, when they flip out, just know that it's going to be does not exist. Okay. When the graphs flip out and go crazy like this one did, kind of look like this, and then there's a whole bunch of stuff in the middle, you don't know what's happening there. It's flipping out. All right. So just realize that when you have crazy graphs like that, it's going to be DNE. All right. So those are the notes for that. There is a packet for this homework, or for this lesson, excuse me. So on the front page of the homework, you're just going to evaluate limits graphically. Then you have some tables to fill out. Okay, and this is just to build some practice. Here's another graph where it's flipping out. Okay, so when it flips out in between, that one's going to be easy. That's just going to be a DNE. Okay. Okay. On the back, you have some more practice with limits. Now, I will give you a hint here. On section 4, it says, what you can actually do on this problem, when you have a limit of a sum, you can actually break that into a sum of limits. So you can rewrite that as this. Okay. You can do that there. You can do the same thing here. And you can write that as the limit of 2f of x as x approaches 0 plus the limit as x approaches 0 of 3g of x. And what you are actually allowed to do, since this is just a coefficient, I can move that coefficient out front, and I can do the same thing here. I can move this coefficient out front. Okay. Now, in order for this to work, both parts have to exist. All right, they both have to exist. If they both don't exist, then the answer is DNE. So just continue to work on those and build some practice. Thanks for watching.